Have you ever wondered how they build the canopies over the large stadiums? Or how about you've been to the Denver airport before? Do you wonder how they build it? Forward Solutions Group is successfully driving companies to succeed where others have failed. Are you looking to start a factory, optimize your existing factory, streamline your production, or take your team to the next level? Whatever your needs are, Forward has a solution for you. Reach out to Ben at forwardsolutionsgroup.com. Halleck Ltd. has a long history of innovation in cold form steel manufacturing and producing innovative precision roll forming technology for customers throughout the United States and the world. Check out their machine buyer's guide for off-site modular construction or fast build construction with light steel for framing. Go to their website, halleckltd.com. Welcome everybody, Dave Cooper. Have you ever wondered how they build the canopies over the large stadiums? Or how about you've been to the Denver airport before? Do you wonder how they build it? Well, wonder no more, because right now we're going to talk with Innovative Technical Fabrics here outside of Munich in Germany. And sitting with me is Michael Wolf and Matthias Meyer. Hi guys.
Hello, Dave.
Hello.
Yeah, perfect. Well, let's start off a little bit with an introduction. So, Michael, why don't you tell everybody a little bit about who you are and how the Innovative Fabrics got started?
Okay, my name is Michael Wolf. I'm one of the 3 directors of ITF. My 2 partners are Barbara Mentil and Hans-Jörg Zabel. So we founded the company ITF in 2013. So this year actually was end of next week. We have our 10-year anniversary party, which we will celebrate at one of the roofs which we did close by here.
Yeah.
And yes, how to start with fabrics. I'm in the fabric business since '91.
Yeah.
I worked for a company previously which was in the fabric business. I executed about 8 world championships, soccer championship stadiums around the world, while one of the stadiums was Kiev, Warsaw, Busan Dome, Nigeria, Abuja Stadium, South African Stadium, one in Johannesburg, one in Cape Town. We also been involved I was involved for the previous company in the stadiums in Brazil,
Yeah.
Maracanã, Natal and Porto Alegre. And one of the projects which I was working on was BC Place in Canada, Vancouver.
Yeah.
And there we actually use different types of material. On the, as you said, stadium roofs like Denver Airport was done with one of our competitors, of the US competitor. And the material is PTFE glass, which can actually withstand UV resistance, is fireproofed and have a lifetime expectancy of 25 up to 50 years. And yeah, it's quite useful for large span structures.
Right. And very technical, and there's a reason we're sitting here and talking about this, but first I want to hear a little bit about what your role is here, Matthias.
So I'm Matthias Meyer, I'm 29 years old and I'm working since 2023. I'm working for ITF Technical Fabrics as a project manager, and I'm supervising the projects, organize them, and looking at all the technical drawings and figure it out how it works.
So you got to deal with all the headaches. You get all the things going on, the technical, the installation, all the things that Michael used to do. You're taking over that position?
I hope so.
Yeah, perfect. So we're sitting here, Michael and Matthias, because one of the things that's very interesting about what you guys are doing is how technical it is, and it is offsite fabricated. Not only just local in Germany, but you fabricate from around the world for some of the biggest projects, $500 million to $1 billion projects, and you're doing it with precision.
That's correct, yeah. So we basically do not only fabric roofs, we also are into mechanical or retractable roofs, which integrates the fabric, steelwork, rails, driving mechanism, control system, how to open, how to close them. So that's all part what we combine together. We are working with cooperation partners on that. We do the entire engineering or subcontract entire engineering. That's why Matthias joined us. His background is mechanical engineer.
Okay.
So he's quite used to use with mechanical parts and all the electronic components which is required for retractable roofs.
Yeah. And we're going to talk about the role here that you're playing in WASH in a little bit as well, because it's about this precision, it's about this large scale production, it is about to manage teams, you know, on a very, very large scale for mass production using very, very precise technology, and that's what you've been known for around the world. Let's talk about some of the projects that you have worked on.
I basically worked in Saudi Arabia on one of the largest projects in the world for fabric structures, which was the Mina project. So the entire side of this, or the entire quantity was 2.4 square kilometers, or in other words, 2.4 million square meters for roofing area, which includes the entire steelwork. So this was one of my main projects in setting up the factories, either in Saudi Arabia or in Sri Lanka, to supply the high demand in a very short period of time on fabrics. But while we also coordinated the entire steel fabrication and installation.
So we're not just talking about the fabrics and some of the products we see sitting in front of us here. You're also talking about the steel fabrication, aluminum fabrication, the cabling system. And the mechanical systems, because some of these are retractable systems.
That's right. On retractable roofs, you basically have to overcome a far distance, which the tensioning load or the pulling load is relatively low. But when you actually come to the final points, you need to tension the membrane to get in a stable position. This means you have to hand it over. So basically on the beginning we're using cable winches to bring it on, and then you basically grab all connection points with hydraulics, and then you pull in the final half meter.
Of the fabric.
So then basically the load goes up significantly.
You're sitting here in Germany, right? This is where you do your design work and planning and everything right here. How do you get this fabric all over the world? And then how, you know, Matthias, how do you manage the scale of people to do a project like this? I mean, this isn't like putting a tablecloth on a table. This is heavy stuff.
That is heavy stuff. Basically, we start off a three-dimensional model. That is a basic thing what we do. Then the three-dimensional model is being taken flat for a huge tailor shop, so to say. And then you assemble your piece of fabric to suit. And you have to make it a little bit smaller because fabric is stretchable. It's not like a steel sheet, so it extends by 2%, 3%. You need to take out your specific tests. Taking this to your account, you do the same with cables. Because all the steel cables, for our concerns, are stretchable or flexible. So what you do actually also on the cables, you preload your cables, you pre-cycle them to take out all the slacks. Then you mark your cables under load. You take it back. Then you cut. Then you swage them. That you know with your designed tension or pre-tension force, you end up with the correct length. This is all needed in your precise engineering. Otherwise, the entire system do not fit on site. Corrected on site, we are building into our engineering system to take off certain tolerances on site. But it's mandatory that also the concrete walls or the fixing points are produced precisely. So we don't care about the structure behind our handover points to certain extents, but the handover points must be within a couple of centimeters.
So when they do the concrete on site, and they do the steel or whatever where you're going to anchor your system to, it has to be to how many millimeters?
Maximum 10 millimeters plus minus.
10 millimeter plus or minus of perfection.
Over 50 meters.
Over 50 meters.
Over 50 meters or 20 meters, depend how many connections points do you have and where your design is. But we can actually design the handover points so you can have some adjustments. And it's also depend on the contractor, where we agree with our contractor, where our termination line is.
So the fabrics for something that large, is that being built local to the project, or where do you make the fabric, or for, I guess, the purpose that you're using it?
The fabric itself, for PTFE glass or PVC polyester, it's different suppliers. But on PTFE glass, you have worldwide 3, maximum 4 manufacturing places. One is in Germany, one is in the US, Merrimack. The other one is in Japan, Juko, and you have another one in Korea, and now China is upcoming.
Yeah.
But which we do not currently not see they have the same quality. Maybe they're coming. Who knows? On ETFE, this is the product there,
Yeah.
which is a transparent film which has no mechanical reinforcement. You have also currently 2 or 3 suppliers in the world which are on the high end. One is in Germany again.
Yeah.
One is in the US, is Saint-Gobain. And you have another one in Italy and in China, in Japan.
Italy, China, and Japan. All right, so these fabrics are being built sometimes hundreds of miles away from where the project is.
Yeah.
You've specified within 10 millimeters, right, over the span of what the accuracy needs to be. And then you're showing up because your product's created to what accuracy?
Our product is created to the accuracy over 20 meters up to 5 millimeters.
Up to 5 millimeters. And so if something's off, does it throw the whole project off?
So far, we never had this subject. We never had this problem.
Yeah.
What we actually do, we fabricated, also as you probably mentioned already, we have several fabrication facilities, and we're also using subcontractors for us to fabricate.
Yeah.
But what we do on our project, we always send minimum 1 or 2 supervisors, depending on the size of the project, to oversee the fabrication if we subcontract.
Okay.
Yeah. So we do all the cutting is done on cutting machines.
Yeah.
So it's verified, and each cut is being measured before you weld it. And when you weld, you do pre-tensioning, you do your methods to end up with the correct length.
Yeah. And when you say welding the fabric.
Welding the fabric, yeah.
Right, not steel.
No, welding the fabric.
Right.
The fabric is a heating process. It's heat welded, so it's not stitched.
Yeah.
It's heat welded.
It's heat welded. Got it. Matthias, talk to us a little bit about like the on-site side of this, the project management side of it, you know, your background in doing some of this work.
So basically, we begin if we go on the site, and so on our position we come when the steel frame is done.
Yes.
So our subcontractors or somebody else is ready with the steel construction. Then we come there with our base profiles.
This is the base profile here.
Yeah.
This
is the base profile there.
Yeah.
And this is for condensation, so a tray, a backup tray. And then we have the membrane itself with the CADA connection and some sealings and the cover plate. So we come with all the stuff and we measure again if everything is right. And if so, we start installing the tray and completely weld the tray. But especially for these ETFE projects. So,
right.
So there we need this.
Got it. And are these trays individually designed per the project, or is it a standard, something that you've designed already and it just works?
Trays can be individually designed for the project, but they vary within limits.
Within limits.
But the trays itself, they are already pre-cut on site. They will just put to the primary steel, and also the aluminium profile is all prefabricated and cut to size.
To size.
On the end of the day, it's basically just going there, screw it down, and fix it.
Let's walk through a couple of projects that you guys have worked on so we can show people the size and scope of these projects. And of course, it's going to drive me to ask more questions as I see this. It's incredible. So what are we looking at here?
Here we are looking at the MRC in Munich, which is the airport center in Munich, which is the connection building between Terminal 1 and Terminal 2. So ITF got the contract to replace 2 membrane fields. And the challenging thing on this part was actually the width is 25 meters and the length is 85 meters.
Yeah.
And through that is PTFE class, we'd be not allowed, or was a special requirement from the client, we're not allowed to do double folding.
Okay.
So therefore we had to lift it onto the roof with a width of 25 meters. And through the neighboring buildings and the tunneling at the airport, there was no possibility actually to place a crane on site or next to the site. So therefore the installation or the lift of the membrane had to be done with a helicopter.
Are those people on the roof? Next
There are people on the roof, you see that,
the size
so
of this, yeah.
the size, it's, yep. So the lift was hanging, or the The package what you see there on the helicopter has about 6 tons.
Yeah.
So we specially brought in a double helicopter, a double rotator helicopter from Switzerland, which been able to lift this load. And yes, again, we prefabricated this stuff in a facility of a related company.
Yeah.
And due to the size, you could not transport 25 meters easily. So we actually established a temporary fabrication facility beyond the airport land. Actually joined and welded the entire field together, rolled it up, and just picked it up behind the runways. Flew with the helicopter parallel to the runways, crossed the runways, landed the piece, installed it.
And they stopped all air traffic so you could do this.
So that they stopped the air traffic for 2-3 minutes. It was just really the time the helicopter was flying parallel to the runway,
To get off.
where the aircraft still starting and landing.
Yes.
And when he was crossing the runway, so the aircraft's been stopped by traffic control for 2 to 3 minutes.
If we go back to that last picture, so the helicopter picks it up, right? It then delivers it,
Delivers it.
and then does it lay on that white portion on the ground there?
No, it lays on the white portion. Yeah, on the roof.
Yeah, on the right. Okay,
On the
got
roof
it.
portion.
And it lowers it down.
We lowered it down, got disconnected, start unrolling, putting it to side, getting secured then,
Yeah.
and then
And
install.
you're using winches to unroll it and hold it tight.
On this particular one, it was mainly running down by manpower and self-weight.
Wow.
Because it's inclined going down.
And it can roll out. Understood. Understood. I mean, that's just a massive project. I will have to go see that before I take off next Saturday for sure.
Go from the airport, you will see it.
I'll mention your name and I'll say I want to see it.
Oh, you see it. It's free entry.
Yeah. Perfect. Great. So, what else do we got here? Because some of the other things are just as, even bigger, like this.
This one was a recent project from us. Was the Reno house in the zoo in Berlin. So Berlin got a new rhinoceros house, and the challenging thing was our supply was the entire steelwork, including the ETFE cushions, which we just talked about before on this.
So this is an inflatable roof system.
It's an inflatable roof system. It's specifically there for insulation purposes. We had used 4 layers.
Yes.
So you have better insulation values.
So then it inflates, and we talked a little bit about this, and it's meant to leak air.
It's not leaking, you can use it a different word. It's saying we have an outless valve.
A valve that does it, and it's easy. You would think that it could get popped real easy, but this is pretty heavy material.
It's heavy, but the material itself, it's quite strong. It's even withstand hailstorms. No problem against hailstorms, it's withstand hailstorms. And it's ETFE. It's a very durable material for UV light.
Yes.
The lifetimes there is 25 to plus years.
25 plus years on a system like this. That is amazing. And the process for installing that, how do you get this fabric up in the air so high and attach it when you have these long spans from one end to the other?
There we had actually walkable working net platforms.
Okay.
So we actually, between the steel arches, we installed workable nets.
That you can move across.
You can walk on it. So you landed on it, you slide in a profile, and then you start clicking it into the base profile.
Into the base profile. And these are all different projects, one-off projects.
They're all one-off projects. There is no repetition of the projects. So within 30 years being in the membrane business, I have not done anything twice.
That's amazing.
That is a picture
Oh, that's the
from
inside.
underneath. That's the inside.
Yeah, so it's clear.
It's clear.
And it allows the sunlight in, which makes for a better experience for the occupants.
Even the top layer is printed to have a certain reflection of the UV light, and you're not transferring too much heat or radiation into the building.
Got it. So it's just not a piece of clear plastic, as you can see.
You see it there, it has some printing.
But that's for the UV light to
It's for the
reflect heat.
reflection. If you don't have that,
Yeah.
at night you have still the same insulation value, but through the daytime you bring in too much radiation,
Got it.
heat radiation. Yeah, and you can play, depending which country, in which area in the world you are, with the size of the fritting and with the density of the fritting.
Depending on where you're at. Yeah. And how about this?
This was a refurbishment of a previous General Electric building.
General Electric?
It was General Electric, but now it's been bought by a German investment company.
Okay.
And it's been part of the Technical University of Munich. So for startups.
For startups. Is that just a replacement roof? That's not retractable?
It's not retractable. That's ETFE roofs itself are not retractable. There are existing ETFE roofs as retractable roofs, but they do not fold into each other. So you basically have a fixed, solid, rigid frame,
Right.
and you move
Cold frame.
the entire frame.
So the entire
You could see that basically you have frames with 2, 3, 4 cushions of 15 meters.
Right.
So you slide the entire system,
Got it.
but it stays fully inflated.
Understood. Wow. Excellent. So what about when you have a retractable system? Like we were looking at here up there, where the whole track system can come back. Is there any issues with the fabric moving and bending?
Then you have to choose a different fabric. So then you have a different limitation of materials. Then you cannot use ETFE.
Yeah.
This would be too brittle. You also cannot use PTFE glass, which is also too brittle. The glass fiber, they would crack
Yeah.
by moving them. Then your choices are PVC polyester, which is that, which also have a limited lifespan, because on PVC, when you move it, the plasticizers will move out.
Okay.
They become brittle when you fold it, and then you get cracks, and they destroy over a period of time the material. But then you have maybe 5 to 10 years.
Yeah.
Then you have Tenara, or ePTFE fabric. It becomes complicated to explain to you. This is basically woven Teflon fibers. Woven Teflon fibers with a special coating on it.
Yeah.
And this is extremely flexible. You can fold up to 100,000 times with no reducing the tensile strength.
100,000 times without reducing tensile strength. Yeah.
But it's very costly. It's extremely costly.
It's very expensive. Yeah.
Yeah.
It's very expensive. So walk me through the process of how this works, right? Does you have an architect? Do they come up with the idea that they want to use a fabric on a building? How do you get involved, and when do you get involved when a project starts?
It's really totally different from project to project. In Germany, currently, the majority is public tenders.
Yeah.
So there you have an architect, an engineer, they design everything, they put it out for tender.
Yeah.
In other situations where it's more private funded project, you'll be very often approached by an architect in a very early stage.
Okay.
You give him advices, you support him, what can be done, what is the best way, how to save money on doing it this way or the other way. So then you're in the project on a very early stage, and you support them until the project has been executed.
Project size. I mean, some of these projects we looked at are huge. Do you do smaller projects as well?
We do smaller projects. We actually do projects, let's say, starting from 100 square meters
Okay.
up to theoretically no limitation.
Yeah. And what are you guys working on now?
Currently, we have a project in Menden, which is a town hall in northwest of Germany. They have PTFE glass high point cones, which the size is 1,000 square meters. It's one cone. And plus 2 other cones by the side of another 200 square meters.
And sounds of it that you guys build all over the world. Doesn't matter where the projects are.
For us, doesn't matter where the project are. As you mentioned in the earlier introduction, I think I worked in more than 25 countries.
On it.
And currently we are working on a project in Bangkok, which we are been already contracted to do the engineering work for hangars.
Okay.
Aircraft hangars.
Yeah.
So the span of each hangar is about a 100 meter span, 2 attached hangars and 80 meters deep.
So you get a project, you design a project, and you say to Mateus, now we have to make this project happen. The build is starting. Just walk me through how that process works and where your jobs begin and where your jobs end on a job site. So you do the design work, you do the fabrication, you come up with the systems, the engineering for if it's a movable roof or not a movable roof, and then the fabrication starts depending on where the project is, how big it is, you'll determine what manufacturing facility is going to build it, correct?
Yep.
The job site's being built, right? The support's being built at the same time the fabric's being developed?
That's correct.
Yep. And then the fabric is shipped to the job site, yes?
Yep.
And that's when you show up. Or are you showing up way before then?
Both. He shows up before.
You show to make sure they're doing everything correct.
Basically,
For controlling, for supervising the manufacturing process, and also to control the steel structure. So they built the steel structure before, and also, or maybe we go there and control and see how it's going,
Yeah.
see how the progress is.
Right.
And then we come up with our membrane, with our system, and then we start with our guys to install it.
And on the fabric side, you guys are responsible for that, but a lot of times with the steel or the cabling system they're using, that could be a different contract. So you're also in coordination with those folks?
depend how our contract is, as you just mentioned.
Yeah.
On the aircraft hangar in Bangkok, we would have the contract including steel. So we select our steel contractor. Obviously, as Matthias said, we will go there, we will supervise, we will make sure that he's following our standards.
Yes.
And we're also taking certain measurements before they deliver, because our responsibility is the same with the cables.
Yes.
We subcontract the cable, obviously, but we are selecting preferred contractors, and still there we're going there and taking control measures.
Yeah, and because the projects are one-off and they're all over the world, you know, the labor to actually install this has a little bit of a learning curve, and I found this very interesting because we were mentioning, you know, the first couple panels could take, you know, a week, 2 weeks, and then all of a sudden, once they pick it up and you have them properly trained and they understand the system, because this is all assembly. They don't have to build anything. They just got to be walked through how to clip it together and put it in place. Is that accurate?
Yeah. That's accurate, yeah.
Yeah. So you're looking at a 2-week learning curve, which is nothing on a project of this size and scope, like stadiums and all these other things. And then it just happens. And you have a very short window to get it done.
That's correct.
Yeah. Why do they give you a short window and everybody else seems to take forever?
Because the roof is the last piece on a building which you put on.
And they want to keep the weather out.
No, everyone else is using up the time.
Yeah.
The designer is using up the time, the client is using up the time for letting the contract go.
Right.
Then you have your general contractor for foundations, primary structure, steel structure, whoever. They are taking all more time than being allowed for normally. And then you have the roof, and when you have a specific finishing day, which you cannot move forward, then you're stuck.
Yeah. Sounds like this has been the norm for your entire career doing this and all over the world doing it. So to me, it sounds like you've just come accustomed to getting it done, being very efficient, installation, the training. Because there's a lot here. You're designing it. In some instances, you're fabricating or outsourcing the
Purchasing it, we're purchasing the membrane,
Yeah.
we're fabricating the membrane, all the other components
Yep.
under our supervision, and then we deliver it and install it.
And train people locally to pull it together.
Yeah, but we bring always a certain team of specialist supervisor like Matthias plus installers.
Well, and that's it. You already have a trained team that does this and knows actually how to do it. Yeah, because some of these projects have hundreds, if not thousands, of people on the projects. Yes.
Yes and no. The one-off project which I mentioned before was the Mina project. There we had up to 6,000-7,000 people on site.
Yeah.
But this included steel and other total infrastructures.
Right.
This was not only the membrane there.
So you're not only coordinating the design, the engineering, the mechanicals, if it's a movable roof, the design of the fabric, the fabrication of the fabric, so and overseeing that. You're also pulling together the steel and the cabling that is needed in the design for the steel and the cabling to match how you're doing your anchor points on your fabric, but also the installation of the steel, the cable points, the fabric, and then obviously the final product.
Yes.
That's amazing.
Including the necessary quality control documents.
And the quality control documents.
We do the quality control,
Yeah.
and the outcome of the quality control are the quality control documents.
Right. And these are designed a lot for commercial use, They're designed for big stadiums or concert areas
Concert
or
area,
airports. So
airports,
high traffic areas.
high traffic
It
area,
has to be strong. It has to be solid, and it also
fireproofed.
fireproofed as well, and aesthetically pleasing.
Yep. This is the job of the architect.
This is the job of the architect. Right, right. Is there anything that we haven't talked about that I should be saying, or you should be telling us?
No, except if you want to put your American satellite dish in there, but...
Yeah, yeah. You've been working on projects like this from around the world for most of your life. And in most of these instances, as a director, so you're running the projects, you have the responsibility of the project, you're overseeing the projects. Some of these projects were up to 7,000 people that were on these jobs. And then you decided that you wanted to start innovative technical fabrics and branch out, and you've built another huge company that is known around the world, and you're doing super innovative things, and you're growing and expanding. Is that accurate?
That's correct, yeah.
So to me, you know, with Matthias, you're really the go-to person in this industry to make this happen for somebody.
That's correct.
That's correct.
So we wouldn't have any problem to execute any projects which been brought to us.
Right. Whether they're small or up to
While
thousands.
small,
Yeah.
we will actually start, as I said before, on 100 square meters
Right.
up to 10,000, 20,000, 50,000, 100,000.
Sure. I think the biggest takeaway for this is the ability to manage so many moving parts, so many people on large-scale projects from around the world is absolutely amazing. And it takes a very unique person, or company I should say, with the experience to do that, because it's not easy.
You need a team.
Yes.
You also need to have a team, which my colleague Barbara actually is an expert in shipping documents and import, export. So it's quite a lot of things in the background which isn't seen, what you need to have as a company which works overseas.
Right.
Yep. So it's a lot of things which needs to be known.
Absolutely. And it's really starting to sink in as to, you know, why your expertise is so needed in WASH as well.
Yep. Because actually I came to join WASH when WASH was started or founded. I've been one of the co-founder of WASH together with my partners. And we've been approached by the Saudi government at this stage to bring them up prefabricated houses.
Yeah.
This wasn't there really available years ago, especially with no timber construction, because in Saudi there is no
trees,
no timber, and they didn't want to import, and they didn't want to have this prefab steel metal houses, which is also available with the sea channels. So they've been more in the clay bricks system because they have clay at their ground. They have clay factories. And yes, we've been approached to come up with some prefabricated houses.
And it makes perfectly good sense to me, right? I'm starting to see the bigger picture and understanding the size of WASH, World of Smart Homes, and the magnitude of what you're looking to do. You're looking to build some mega factories that are putting out thousands and thousands of homes a year around the world. And it takes a team of people such as yourself with the expertise to be very precise and to be able to know how to set up factories and manage manufacturing from not only a job site level, but a factory level, and then bring it all together.
You need to have people which have different backgrounds and different technologies. You need to team them up and bring them together and get them to work
So
as a team.
That's right. So stay tuned. We're traveling in Germany, Austria, and Italy, and we're here to learn about the team of WASH and what they are doing, the partners in WASH, and what their backgrounds are and why this is going to be the next wave of the future. I'm Dave Cooper. Thanks for watching. What an amazing show. Thank you to all of our sponsors for helping us to continue to bring all of these innovative conversations to all of you out there. Please visit them, see what they have to offer you, and as always, subscribe to the YouTube channel and ring that bell. It would mean the world to us. I'm Dave Cooper. Thanks for watching.